So I'm saying that there are various classes of organic compounds, the simplest organic compounds being alkanes. Another group of compounds, organic compounds, we have alkenes. Then we have other groups of organic compounds like alkynes. So these were totally exhausted in ordinary level. In O level, you learned about alkenes, you learned about alkynes, you learned about alkanes. So those were the different classes of compounds. But here we shall also look at aromatic compounds. For example, benzene and its derivatives. We shall also look at esters. We shall also look at alkyl halides. We shall also look at amines. It is only a matter of time to exhaust, but there are very many. So I know you looked at alkenes in the class, so I want to begin alkenes. But there is something common about all these classes of compounds. When I have finished maybe learning about alkenes, what do I know about alkenes? I should know the general formula of alkenes. If I have studied alkenes, I should also know the general formula of alkenes. After I have studied alkynes, I also need to know the general formula of alkynes. Just like also benzene. These are aromatic compounds. So for any case, organic compounds, these are not only compounds which have carbon, but we also have aromatic and then alicyclic. Aromatic compounds are the ones which have the benzene ring in them. This is a benzene ring, it is hexagonal in shape. This length is similar to this length, which is similar to this length, also similar, and then so this one is similar. Then I put double bonds. If I put here double bond, I jump here. Put here double bond, jump this one. Put here double bond, jump what? So any compound which has a ring of benzene in it, it is aromatic. Any compound which has a ring of benzene is aromatic. Then we have compounds which are just alicyclic. For example, this compound itself is alicyclic. We have maybe a pentagon in form of it can be like this. Also, this is alicyclic. Of course, naming them will depend on the number of carbon atoms. But we can also represent a benzene ring with a cycle inside that hexagon. So if I put a circle like this, that circle should not touch either sides of this should not touch either sides of that hexagon. So we have those compounds. We have alicyclic hydrocarbons, we have aromatic hydrocarbons, then we have hydrocarbons which are aliphatic. So under that organic, I need to understand the real basis. It's of course an organic chemistry. I'm dealing with hydrocarbons, but we have those hydrocarbons which are aliphatic. We have hydrocarbons which are alicyclic. Then we have hydrocarbons which are aromatic. What do I mean by hydrocarbons which are aliphatic? Hydrocarbons which are aliphatic are the ones which are actually just chains. They have chains of carbon. For example, you can have a compound like ethene. It is in chain form. It can either be branched or linear. Alicyclic, they are the ones which are now like this. It can even be just circular like that. It can even be triangular. This one cannot. It can be triangular. I can put here carbon atom, put here carbon. It is actually totally saturated. Then aromatic, you have said that all compounds which have benzene in them are aromatic compounds. So which means that when I mention of the word aliphatic, I should be cognizant of it, or I should be very much aware of the word aliphatic. When I mention the word alicyclic, you should be also aware of it. When I mention the word aromatic, you should be aware. So I know you said alkanes, but which means that I should know the general formula of alkane. These are the general things I have to know on every class of compounds. Then I also need to know the general formula of alkenes, general formula of alkynes, and then so on. Apart from identifying the general formula, I also need to know the nomenclature. I need to know the what? The nomenclature. Nomenclature means that the names. Do I know how to name an alkane? Do I know how to name alkenes? Do I know how to name alkynes? Of course, for any nomenclature, you have to follow the rules of nomenclature. And when you are going into deep introduction of, just introduction to organic chemistry, they must have taught you the rules to follow while naming organic compounds. I don't want to repeat the rules, but of course you can repeat by reading. By what? By reading. So I need to understand the nomenclature. After I've taken time to understand the nomenclature of those compounds, I also need to take my time to understand the physical properties. Remember that I am a new curriculum student, so these things should be taken with understanding. I should not start cramming. When I tell you what is the set symbol of ethene, what is the set symbol of what? Of ethene. What is the set symbol of hexane? They are not the same. I should know that these organic compounds from C1 to C4, which means that the elements which have carbon atoms ranging from 1 to 4 carbon atoms, they are all gases. So I need to understand that then from C4 to C17, these are liquids. So realize that as the number of carbon atoms increase, also now the state changes from solid liquid, from a gas liquid up to a what? A solid. So apart from physical properties, I need to know the chemical what? The chemical properties. So generally, if I'm in alkenes, if I'm to test you, I'll test you on the what? Nomenclature. Do I know how to name alkenes? Can I tell some of the physical properties of alkenes? Like what physical property of alkenes do you know? You know that they are then chemical properties of alkane. Alkanes generally reactive, they are generally unreactive. So that is why in most synthesis we shall not involve alkanes, because they are generally unreactive. Although we have chlorination of alkanes, but they are not too reactive like another class of what? Of compounds. Then from there, the major part of it, apart from knowing chemical properties, physical properties, nomenclature, and then the general formula, of course these ones here can miss, but what may not miss, of course, is isomerism. I should know, the different types of isomerism. So which means that I should know how to alter these structures so as to come to the different isomers. So if is it functional isomerism? Is it what? So I need to know the major three types of what? Isomerism. Then how do I apply it to alkanes? How do I apply it to alkenes? How do I apply it to alkynes? Then, as I told you, of course, the more you or the higher you go, the more the chemistry becomes sweeter. Then from there, I'm going to be now understanding ways of preparations, or preparations of what? Preparations of alkenes. I should know how to prepare alkenes. Then finally, we now look at the reactions of alkenes. When I know the reactions of alkenes, I can now look at the questions. Very many questions in alkenes. What you have to know here, that alkenes forms the major basis of organic chemistry, and therefore you should have a strong foundation in alkenes. And what is that strong foundation? Is talking about the preparation of alkenes, and then talking about the reactions of what? Of alkenes. So as a student, you are going to discuss, I know you have the brother, you are going to discuss in groups. I want you to tell me, to write for me short notes, and I've not told you to go and use maybe a textbook. No. Yeah, you can research as long as you have understood. Then you are going to send me a voice note, of course showing the video or showing how you have or you are going to send me written notes on the general formula. Do I know the general formula of analukene rather? Then nomenclature, this one you can jump, or although you can, of course, for you to perfect nomenclature you should do continuous revision. For example, let me give an example of an aliphatic analukene. For example, this can be this CH2 CH3. So you realize that this is maybe CH. You should know that when I'm writing these compounds here, carbon should have the full 4 bonds. If I write like this, you realize that carbon is having only these are 2 hydrogen atoms plus the bond between this carbon atom and this carbon atom. So realize that this carbon atom alone, this carbon at position 1 is only having 3 bonds. There's this bond. So if I expose this compound, I'm having C. I have 2 hydrogens. Let me put that one there and that one. Then there's another bond linking this carbon and this carbon, which is there. Then I have this bond. Then I have this bond having the CH3. Then I have the double bond. I have this C. I have the 2 hydrogens. Then I have that bond also. So how do I know that my formula is correct? If a formula is correct in these organic compounds, carbon should be fully bonded to 4 to 4 other atoms. For example, we have here carbon, this carbon atom in position 1. This carbon has 1 bond. When you say bond, this line here connecting one atom to another is a bond. So how many bonds are on this carbon? We have 1, we have 2, we have 3, which means that here this carbon is not fully bonded, which means that this formula cannot be correct. What is the right formula? When I add another bond and of course the hydrogen attached to it. So in this case, carbon is fully bonded. So you should take cautious. When I also count the bonds here, these are 1, 2, 3, 4, 5, which means that this bond, this carbon is now over. It is having very many. Remember that carbon is only fully bonded when it has 4. It cannot take less, it cannot take more. So it means that I have overloaded. So I have to remove out 1 bond, and particularly I'm removing out the carbon hydrogen so that this carbon has 1, 2, 3, and then a 4. What about this carbon? This carbon has 1, 2, 3, 4, 5. You see, which also it is fully loaded. So let me remove out this. When I remove out this, I'm meaning 1, 2, 3, 4. How about this carbon? This carbon has 3 hydrogens and then this one, which means there are 4. So what is the correct formula? The correct formula is going to be C. Now I'm writing a condensed formula of this compound here. Then I'm going to name it. So here there are 1, 2, 3 hydrogens. So this is CH3. Then connected to it, there is a carbon, there is an H there, and then there is a side bond here containing a methyl group. Then there is a double bond there, but this hydrogen we have removed, so it is not there. So generally it is going to be CH3, C. This hydrogen is not there, but I have here CH3, then a double bond, C. This hydrogen is not there, but this hydrogen is there, which is that one, CH3. So now I want to name that compound. Naming this compound here, I'm going to follow what? I'm going to now first of all look at the parent chain. What is the parent chain? The parent chain is the longest chain. For example, I might have this chain here. You see, this can form a chain. Also, this one here can form a chain. Also, this one here can form a chain. So if I follow this one, this is 1, 2, 3, 4. So this is carbon at position 1, carbon at position 2, carbon at position 3, carbon at position 4. When I'm moving from from left to right, I can still move like this, but these are only 3 carbon atoms. I can still move like this, still I form 4 carbon atoms. So I choose, so either to move like this or to move like that. So when I move like this one now becomes my side chain. When I move like this methyl here becomes my side chain. But me as a steady man, I'm taking this movement here like this. So when I move like this methyl here is going to become my side chain. Are we together? So when it becomes side chain, I now start counting. This is carbon is at position 1, this carbon is at position 2, but between this carbon and this carbon there is a double bond. So I start, if I'm moving in this way, so this double bond is at position 2. We now don't use the 3. We are going to say that it is at position 2. So if I'm to name, and also this side chain is at position 2, still here. So I'm going to say this is 2. This side chain is called a methyl, so that is a 2-methyl. 2-methyl. The parent chain here has 4 carbon atoms. So if it has 4 carbon atoms, the parent name automatically should be bute. So but because it is an alkane, it's going to be butene. But I have to be specific on the position of the double bond, and therefore it is going to be 2-methyl bute. The double bond is in position 2, so it is bute 2 in. It is only the first set is one which is capital. The remaining will be following as small. There is no spacing. This 2 is a positional relocant. When I have 2 of them, I separate them using a what? Using a comma. But a locant and the name is separated using a hyphen. So this one is called 2-methyl bute 2 what? Bute 2 in. In brief, the general formula of an alkene is CnH2 what? H2n. So I want you to make me notes on general formula of alkenes, nomenclature, and you just give some few examples. We also do physical properties. You have to write some, at least 3 physical properties. Also write for me chemical properties of alkenes. Then which types of isomerism do alkenes exhibit. Then you give various examples, because I'm going to question you, or I'm going to give you a task. I'm going to give you a test involving this. But now I'm beginning on the preparations. I want you to do that. Don't be lazy. Please comprehend. So let me send this video. Then I prepare another one on this current chapter.